I need somebody to hear, somebody to know, somebody to have, somebody to hold. It's easy to say.
Determinant of 3 by 3 matrices. The determinant of 3 by 3 matrix can be evaluated as the sum of the product of the elements of any one row or column with their respective cofactors. So, determinant of 3 by 3 matrix can be found by using the expansion of the cofactor. Okay, so determinant A is equals to summation of element I row j column times with its cofactor, where I is row 1, row 2 until row n, and j is column 1, column 2 until column n. Look at the example to find determinant A by expanding along the first row. Element in the first row are element row 1 column 1, element row 1 column 2 and element row 1 column 3. Then determinant A is equals to all elements in row 1 multiply with its cofactor. The same thing applied when expanding along the first column. So you can choose any row or column in order to find determinant of 3 by 3 matrix. Choose row or column that has the most zero. Okay, now look at to the example 3. Given matrix A and matrix A is 3 by 3 matrix. Find the determinant A by choosing first row and second column. Okay, so here is the first row. So to find determinant A by choosing first row, use the cofactor expansion of all elements in row 1. Okay, then determinant A is equals to the element of row 1, column 1, which is 4, times with its cofactor. Do you remember how to find the cofactor? Okay, negative 1 to the power row 1 plus column 1. Then delete its row and column. Then write the resulting determinant. Okay, for the second element of row 1 column 2. So we have element 10 times its cofactor. Negative 1 to the power row 1 plus column 2. Then delete its row and column. So write the determinant, and then the last element of row 1, which is element row 1 column 3. So the element is negative 2 times its cofactor, negative 1 to the power row 1 plus column 3. Then delete its row and column. So write the determinant, and then simplify the cofactor expansion. So we have 4. Then by using AD minus BC, we have negative 9 minus 15 plus negative 10, and then times with 24 minus 30, then plus negative 2 times negative 24 minus 18, and the answer for determinant A is 48. Next, find determinant A by choosing second column. So here is the second column. Then use the cofactor expansion along the column. Then determinant A is equals to the element in row 1 column 2, which is 10, times with its cofactor. So negative 1 to the power row 1 plus column 2, and delete its row and column. So write the resulting determinant plus the second element of second column plus negative 3 times its cofactor, negative 1 to the power row 2 plus column 2, delete its row and column. Then write the resulting determinant and plus the last element of second column, which is element row 3 column 2. So negative 3 times its cofactor, negative 1 to the power row 3 plus column 2, then delete its row and column, then write the resulting determinant. Simplify the expansion of the cofactor. So negative 10 times AD minus BC, then we have 24 minus 30 and plus negative 3 times 12 minus 12, then plus 3 times negative 24 minus negative 16. So determinant A is equals to 48. Therefore, we will get the same value of determinant A if we choose any row or column. Look at example 4. Find the determinant of A, and A is 3 by 3 matrix. Tips: choose row or column that has the most zero. Look at the element of matrix A. First row and third column has the element of 0. So you can choose either one in order to get the determinant A. Now I want to choose first row to find determinant A. So use the cofactor expansion along the first row. Then determinant A is equals to the first element of row 1 column 1, which is 2, times its cofactor, negative 1 to the power row 1 plus column 1, and then delete its row and column. So write the resulting determinant. Okay, then go through to the second element of row 1 column 2, which is negative 2. Then time is cofactor, negative 1 to the power row 1 plus column 2. Delete its row and column. Then again, write its determinant. And the last element of row 1, which is 0. So, for the last element, we don't have to write its cofactor because the expansion will be 0. Okay, then simplify. So we have 2 times negative 1 plus 12 that we get from AD minus BC. Then plus 2 times 3 minus negative 6. And the answer for determinant A is 40. Properties of determinant. So first properties, if a square matrix B is obtained from a square matrix A by multiplying each element of any row or column of A by some real number k, then determinant B is equals to k times determinant A. Example 5. Given determinant A equals to 5, hence find determinant B, C and D by using the determinant properties. First, find determinant B. Write matrix B in determinant form. Look at to the first row. 5 is the common factor for the elements of row 1. Take out common factor 5 from the determinant, and if we can see that element in determinant is similar to determinant A. So we can write as 5 times determinant A. Given determinant A is equals to 5, so we have determinant B is 25. Then find determinant C. So first, write matrix C in determinant form. Look at to the first and second row. So if you can see that 5 is the common factor for the elements of row 1 and row 2. Then taking out 5 from the determinant. So element in determinant is similar to determinant A. Then we can write as 5 times 5 times determinant A. So we can also write as 5 squared times 5, and determinant C is equals to 125. Last, find determinant D. So first write D in determinant form. Look at row 1, row 2 and row 3. So we can see that 5 is the common factor for the elements of row 1, row 2 and row 3. So take out 5 from the first, second and third row. Then we have the element in determinant similar to determinant A. The answer should be 5 times 5 times 5 times determinant A, or we can write as 5 cubed times 5. So the answer for determinant D is 625. Second properties of determinant. If a square matrix B is obtained from a square matrix A by interchanging any two rows of or column, then determinant B is equals to negative determinant A. Look at example 6. Given matrix A, then write matrix A in determinant form by using AD minus BC, 2 times 4 minus 3 times negative 1. So determinant A is equals to 11. Given matrix B, matrix B are getting from interchange of row 1 and row 2 of matrix A. Then matrix B is negative 1 times 3 minus 4 times 2 and is equals to negative 11. Therefore, determinant B is equals to negative determinant A. Third properties of determinant. If A is a square matrix, then determinant A is equals to determinant A transpose. Look at example 7. Given matrix A and determinant A is equals to 11. So first find A transpose. Element in first row of matrix A are transposed to be element in first column of A transpose, and element in second row of matrix A are transposed to be element in second column of A transpose. Then find determinant A transpose. So we have 2 times 4 minus negative 1 times 3. Then determinant A transpose is equals to 11. If we can see that determinant A is equals 11 and determinant A transpose also equals to 11. Therefore, determinant A is equals to determinant A transpose. Fourth properties of determinant. If A and B are square matrices, then determinant AB equals to determinant A times determinant B. Look at example 8. Given matrix A and matrix B, the determinant A and determinant B are 11 and negative 14 respectively. In order to show this property, find matrix AB by multiplying both matrix. And here is the matrix AB. Then find determinant AB. Write in determinant form by using AD minus BC. So 11 times negative 12 minus 2 times 11. Then we get the answer is negative 154. From the questions, given the determinant A and B are 11 and negative 14 respectively, so determinant A times determinant B is equals to 11 times negative 14. The answer for determinant A times determinant B is negative 154. That means determinant AB is equals to determinant A times determinant B.